a mass of 2 kilograms rests on the inclined surface where the coefficient of friction is 0.4. Connect to a mass of 4 kilograms hanging vertically by a light string passing over a smooth pulley. Now they say find the solution of the masses. B. If the string is caught after they have been moving for 1 second, how much further will the 2 kilogram mass travel up the plane? Now, this is a problem. This is a figure. This is the 2 kg on the inclined plane. This is the mass, 4 kilograms. So now let's work this thing out. So now the way to do this, let's go down here. We'll draw a free body diagram of the masses. So now you have the 2 kg mass on the inclined plane. Now from here you have the normal reaction, which is N. The weight of the object, which is 2 times acceleration due to gravity. Now the thing is accelerating up, so now the acceleration is this, which is A. Now resolving this acceleration, resolving the weight of the 2 kg along and vertical to the plane. So now if we now draw a line like this, here will be 30, because let's say this is a plane. You have here starting and here is 90, so that means here is what, 60. And since this one is perpendicular to this, so here the whole of here is 90, so 90 minus 60 here will be 30. So that is how we got that. Now to resolve the weight of this 2 kg along perpendicular to this plane, to the inclined plane, you now have here. Now let me say I resolve it. Now I have something like this. Perpendicular to the plane, then this one along the plane, then we have the normal reaction, which is N. Then there is an acceleration up here. Now there is a tension here, which is T. So the tension here, which is T, will also be written. Now resolving this 2g, which is the weight of the 2 kg mass, the weight, resolving it along and perpendicular to the plane. Now this one is along the plane, so with here being 30, along the plane will now be 2g sine 30. Then this one perpendicular to the plane, this one will be 2g cos 30. So now, with this free body diagram, with the free body diagram, for this case, I will now assume this is my y axis and this is my x axis. So now the summation of forces in the y axis will be equal to 0. There is no acceleration along the vertical axis because the thing is on a plane and it does not move up or down the plane. So the summation of forces along the vertical, that is the summation of forces perpendicular to the plane is 0, because the object is not jumping up the plane or moving into the plane, so it's just on the plane. So the summation of forces will just be equal to, the summation of vertical forces will be equal to 0. So meaning, and the up is positive, so meaning you have n is positive minus 2g cos 30 equal to 0. Now, you know there is also a frictional force on the plane, and the frictional force is N is mu, as in the coefficient of friction, times the normal reaction. So we have this. So isolating N, you just add 2g cos 30 to both sides of the equation. You have N is equal to 2g cos 30. This is equation 1. Now, the next one, the summation of forces along the x-axis will be equal to the mass of the object times the acceleration, because the body is accelerating. Now there is just like, so the body is accelerating, so there is a motion. So now there is a change in velocity. So since there is a change in velocity, there is an acceleration. Now, and since there is an acceleration, there is an applied force. So there is an applied force. That is why the sum of all the forces along the x-axis, which is along the plane, is equal to mass times the acceleration. So this direction is positive. Now, meaning the tension is positive, minus 2g sine 30 minus the mu times n is equal to the mass, which is 2, times a, which is the acceleration, which we don't know. We're asked to find a. So now this should be our equation 2. So substituting n equal to 2g cos 30, you have t minus 2g sine 30 minus mu minus 2 mu g cos 30 equal to 2a. Let me call this equation 3. Now we have gotten this. We've expressed this. Then now let's go over to the 4 kilogram mass. So the 4 kilogram mass, you have the weight acting down. That is 4g. The tension here. Now it is accelerating the same with the 2g mass. Now you only have vertical forces. There is no sideways. Since the body is not moving sideways, so it's only one kind of directional motion and one directional forces. So let me now, for this body, let me say local definition of the coordinate of these forces. I will say here is y, this is x. Now the forces along the x-axis is, there is no forces along the x-axis, so I will not consider that. Now the forces along the y-axis is equal to the mass times acceleration. Now the forces along, let's say the vertical forces is positive, Now you have t minus 4g equal to 4a. Now but the body is moving down here. The body is moving down, so invariably, okay, let me just leave it at that. So but let me use the direction of flow, the direction of the motion. So because the direction of motion defines how the object will move. So now let's say, since it's moving down, I will now have 4g minus t equal to 4a. This should be equation 4. Now if we decide to add equation, adding equation 3 and 4 together, now let me bring it down. We have t minus 2g sine 30 minus 2 mu g cos 30 is equal to 2a. This is equation 3. If you add them together, these tensions will cancel each other. You have 4g minus 2g sine 30 minus 2 mu g cos 30 is equal to 6a. So that is it. Now we can solve this. You know, g is equal to 9.81 meters per second square. You have the mu to be 0.4. So now substituting this, we can solve for our a, which is the acceleration. So now we have 4 times 9.81 minus 2 times 9.81 times sine 30 minus 2 times 0.4 times 9.81 cos 30 is equal to 6a. Now let's use our calculator to solve this. Now let's call up the calculator. Now we have 4 times 9.81 minus 2 times 9.81 times 30 sine minus 2 times 0.4 times 9.81 times cos no. Let me 9.81 times 30 cos 4 times this, 2 times this, minus this time, okay, equal to 22.633. So we have 22.6334 equal to 6a. So isolating a, you divide all through by 6. And that means our a is equal to, because this cancels this, the right hand side will now be a, so a is equal to 22.6334 divided by 6. This will give us divide by 6 to give us what? This will give us 3.77 meters per second square. So that is the answer for that. Then now they said if the string is caught after they have been moved for 1 second. So now the system has been moving for 1 second and the string is caught. Now after the string is caught, what is the distance? See what is the distance or what? If how much further will the 2 kilogram mass travel up the plane? How much further? So now this is our A part, this is the B part. This is the B part. The B part, they are asking how much further will it move. So now it has moved for 1 second. Having moved for 1 second, that means we need to calculate the final. Now let's say this is the object. Let me just represent it with a small. Now it started at 0.0. It now moves to a point at this point. at this point, which is 1 second, which it have moved, and at this point the velocity, we need to get the velocity at this point when the string is cut, at the point, at the spot, at the instance where the string is cut. We need to get the final velocity at that point, at that time t equal to 1 second. So now, to do that, we knew that acceleration is equal to the final velocity, the change in velocity, all over the change in time. So the change in velocity will be the final velocity minus the initial velocity all over the time taken. So now the final velocity is what we're looking for. Now it starts as time 0. It starts at initial velocity, which is 0. Now within 1 second, now we know our acceleration. So now from this expression, you have v minus u is equal to at, and v is equal to u plus at. Now since u is equal to 0, the initial velocity, and at time t equal to 1 second, the final velocity will now be 0 plus the acceleration, which is 3.77 times 1 seconds, which will give us 3.77 meter per second. Now we have gotten the velocity, the final velocity at the instance when the thread is caught. Now what they are asking us to get now is how far will it go from that point when the thread is caught to the point where it will stop. Now at this case, the final velocity becomes the initial velocity. So the final velocity, or at this case, becomes the initial velocity. Then the final velocity at the point where it stops will be equal to 0. Now we know that acceleration is the same thing as v minus u all over t. It now implies that t is same thing as v minus u all over a. Now we also knew that the distance, which is what we're looking for, is the same thing as the average, speed times the time. Now the average speed is just adding the final and the initial velocity divided by 2 times time. Now you have v plus u all over 2 times the time, which is v minus a minus u all over a. So that means x is equal to v plus u all over 2 times v minus u all over a. Now if you expand this, you have v square minus u square all over 2a. Now we are looking for how long it will move after the rope must have been cut. Now for the scenario where it moves 1 second before the rope was cut, the final velocity at that condition will not be the initial velocity for this. So now, this is the formula for the displacement. The further the object can go up the inclined plane. So now, since the thread is cut, the free body diagram of that mass on the inclined plane, there will be a change. So this tension here will not be there again. Now the body is moving up the hill with a deceleration. It's moving up the hill with a deceleration. So, and now the weight component of the object that is moving down along the plane will be 2g sine theta. Now you have the frictional force, which is 2 mu times g cos theta. So these are the only forces acting along the y-axis of the plane, along the inclined plane. So the summation of forces along the x-axis, which is along the inclined plane, x, will not be equal to the mass of will be equal to the mass of the object times the deceleration. Now we need to find deceleration of the object. So now for us to find the deceleration will not be 2g, which is the force down the hill, plus plus 2 times mu times cos theta. Now this is a negative force, because since along the plane, since the x-axis along the plane is positive, up the plane is positive. Now the whole of this will be negative, equal to, because it's moving down, equal to the mass times the acceleration, which is deceleration. Because if you have a negative value, if acceleration has a negative value, it's deceleration. The mass is 2 kg times a. Now that means we have 2a equal to minus, in bracket, 2g sine theta plus 2 mu g cos theta. And our theta is 30, so you have 2g sine 30 plus 2 mu g cos 30. So this is the same thing as saying minus 2g in bracket sine 30 plus mu cos 30. Cos 30. So that means dividing all through by 2, this will cancel this. At the left hand side you have a. If you cancel this, if 2 cancels itself, you have at the right hand side you have minus g into sine 30 plus mu cos 30. Now using our calculator, let's bring our calculator. Let's bring the calculator. Let's type so you select this. So G is 9.81 times bracket open. Is it divide I used there? It's divide though. Let me say 9.81 times bracket open 30 sine plus 30 cos times 0.4, which is mu, bracket close, equal to so the answer will be minus 8.303 meter per second square. So this is the deceleration when the thread is caught. Now what we'll now do, we use this. Now we have the formula that we're going to use to find how further the object will go, the object on the inclined plane will go. So now the distance it will go is, which is equal to v square minus u square all over 2 times a, which is the acceleration. In this case is deceleration. So now at the point where it stops, that is how further it can go, the velocity at that point, the final velocity at that point, the final velocity at that point is equal to 0. Now the initial velocity it will take is it will now be the velocity of the final velocity at the point when the rope cuts, which is 3.77 meters per second. So it will now be 3.77 meters per second. So now if you substitute this, you have A to be equal to minus 8.3033 meters per second. If you substitute into this equation, we have S to be equal to 0 minus 3.77 square all over minus 2 times 8.3033. Now what will this give us? Now let's use the calculator. So you have 3.77 square divided by 2 divided by 8.3033. Now we have 0.86 meter. That is how far it will go. Okay, let me just call it 0.56 meter. So this is how far it will go before it stops. Now thank you for watching. Have a nice day. If you like this video, please subscribe to my channel and hit the notification bell so that anytime I create new video, you'll be the first to watch it. And also do well to share the video. Thank you.